Intermediate Algebra for Statistics, Using the Slope of a Line, Part 2. Lesson objectives: compute the slope of the line, state if the slope is increasing, decreasing, zero, or undefined. We'll begin with an example. Find the slope of the line that passes through 3, 5 and negative 1, 4. To answer this problem, we first have to use the formula for slope. y2 minus y1 over x2 minus x1. I'm going to let this be y2, 4 minus my other y coordinate, which is 5, over, since I use this 4 when I do my x coordinate, I have to use negative 1, and I have to subtract my other x coordinate, which is 3. 4 minus 5 is negative 1. Negative 1 minus 3 is negative 4. Negative over negative is positive, so the answer is 1/4. Now for this problem, we are given a graph and we're asked to find the slope. So I'm going to pick 2 points. This point is on the line, and so is this point. And what we want to do is we want to use the formula. This time, since we have a graph, it's probably going to be easier to use our rise divided by our run. So if I go from this point to this point, the rise would be negative 1, negative 2, negative 3, negative 4. I went down 4 units. And as I go from this point to this point, I went over a positive 1, positive 2. So the run is a positive 2. And negative 4 divided by a positive 2 is a negative 2 over 1, or we just say negative 2. So the answer is this one. Lesson objective number 2. Slopes of increasing and decreasing lines. An increasing line has a positive slope. If we look at the graph from left to right, like we're reading a sentence, if the graph is increasing, going uphill, we have a positive slope. A decreasing line has a negative slope. So as we read the graph from left to right, this is going downhill. This has a negative slope, as this is a decreasing line. In general, for 2 non-parallel increasing lines, the steeper the line has the greater slope. So if we look here at the green line, which has a slope of 1 over 2, a half. The red line has a slope of 1. It's larger and the line is steeper. If we look at the blue line here, this has a slope of positive 2, so it's even larger than this line. And this also works going in the negative direction. Example 6. Find the slope of the line that contains 3, 2 and 7, 2. So if we pick our points here, y2 minus y1, we get 0, and x2 minus x1, we get 4. 0 divided by 4 is 0. So whenever we have a horizontal line, the slope is always 0. Example 7, we're going to compute the slope for the points 3, 1 and 3, 5. So if we take our y coordinate, 5 and subtract our other y coordinate 1, we get 4, and then we take 3 minus our other x coordinate 3 and we get 0. Now 4 divided by 0 is what we call undefined. And it turns out that any vertical line, the slope is undefined, does not exist. Slopes of horizontal and vertical lines. A horizontal line has a slope equal to 0. A vertical line has an undefined slope. Sign of the slope. Here we have a series of different lines. Which of the lines have a positive slope? Going by the color. The green one and the blue one have a positive slope. Which have a negative slope? The red one, the light blue one, and the gray one. This line is undefined. It is vertical. And this line here, the slope is 0. Example 8. Before starting a diet, a person weighs 160 pounds. While on the diet, she loses 3 pounds per month. Let W be the person's weight, measured in pounds, after she's been on the diet for T months. The equation is W equals 160 minus 3T. Perform a unit analysis of the equation using the slope. So we know that W is pounds. 160, her starting weight, is in pounds. The negative 3 is our slope. And slope is the change in the y over the change in the x. So that's pounds per means to divide, month. And our independent variable t is months. To perform the unit analysis, we want to see, does the left hand side and the right hand side have the same units? So since we know that W is pounds, the left hand side is pounds. The right hand side will be pounds minus pounds per month times months. These units cancel and we're left with pounds minus pounds, which is equal to pounds. So the units on both sides of the equation are pounds, which suggests that our equation is correct. Thanks for watching.